Hello everybody, Mr. B here again for another video in the fraction series. And I think this is the last video, at least the last video that I've got going for now. I may come up with some later, but this is video 10, fractions and decimal numbers. So we'd like to see what the relationship is between fractions and decimal numbers. So what if we want to convert fractions into decimal numbers? We simply use long division. Remember, a fraction is division. 3 over 4 means we're dividing 3 by 4. So here's the long division bracket. 4 goes into 3, but it doesn't go into 3. 4 is bigger than 3, so we have to add a decimal point and put another 0 there. And now we can ask, how many times does 4 go into 30? Well, it goes 7 times. And we need to put a decimal point right where the other decimal point was. All right, so now we multiply 7 times 4, we get 28. Then we subtract. 30 minus 28 is 2. We have to put another 0 and bring that down. 24 goes into 25. Multiply. 5 times 4 is 20. And we don't have any remainders, so we're done. This decimal number terminates, meaning that there's just zeros to the right. So 3/4 equals 0.75. That was easy, right? Okay, so it's long division. This video is not about long division. You'll have to, if you don't know how to do long division, I suggest you go to a arithmetic book, or a pre-algebra book would be suitable. I'm sure there's many resources online. Okay, next example. 1/3. Something interesting happens with 1/3. So we divide 3 into 1, can't do it. We have to add a 0 here. So a decimal point and a 0. Maybe I'll put the decimal point right away where it goes, right there. So now we ask, 3 goes into 10 3 times, then we multiply and we get 9. We subtract. 10 minus 9 is 1. We add another 0 on there, and wow, we have to divide 3 into 10 again, and we get a 3. We get another 9 when we multiply. We subtract, we get a 1. Then we bring another 0 down, and we keep getting 3s forever and ever and ever. So 1/3 is 0.33, and then sometimes people put 3 dots, or even better is, I usually like to write the thing that's repeating twice and then put a bar over the thing that's repeating. We might round 1/3 to something like 0.33, but we have to remember that this 0.33 is not exact. We don't, if we're not including all the other 3's, then there's an infinite number of them, that this 1/3 is just approximated by 0.33. This squiggly symbol here is approximately equal to. Okay, so when we write the decimal representation of a fraction, sometimes it terminates and sometimes it doesn't. It repeats. Fractions come under the heading of rational numbers, meaning, well, the word ratio is in rational. Rational numbers. Rational numbers. And it's a set of numbers. You can see the word ratio in the word rational. So all these fractions we've been dealing with are part of the rational number set. There's other number sets too. But rational numbers are characterized by decimal numbers that either terminate or they repeat. Okay, what's next here? Yeah, this is just a note about how don't use rounded numbers to think you're getting the exact value, right? Rounded numbers are approximations of fractions that have a repeating decimal representation. Okay. How about a mixed number situation like this? Well, remember, 10 and 5/8 is really 10 plus 5/8. So if we could get the decimal representation of 5/8, we could add that to 10 and we'd have the full decimal number. So what's 5/8? We're dividing 8 into 5. Again, we have to add a 0 to even start doing the division. 8 goes into 50, 6 times? 6 times 8 is 48. Subtract, we get 2. Add another 0. 8 goes into 20 twice. 2 times 8 is 16. Then we subtract and we get 4. Bring down another 0. 8 goes into 45 times. Multiply and we get 40. And then finally we get a 0 remainder. So it's going to be zeros everywhere else. So what we have here is 10 plus 0.625, and we add that and we get 10.625. So that's the decimal representation. A calculator will do these things easily, but it's nice to know what's going on inside that calculator. How about this one? We know that 10 1/3 is really 10 plus 1/3. But we saw earlier in a previous example that 1/3 was 0.33 bar. So this is really 10.33 bar, which is only approximately 10.33. The more threes we put on there, the more accurate the number gets, but it's still approximate. We'd have to add an infinite number of threes to make it exact. This is an exact number. When we put the bar there, we're saying we're going to infinity. So 10 1/3 is 10.33 bar. Okay, how about converting a decimal number to a fraction? What we have to do is look at the decimal part to the right of the decimal point. And if it terminates, then it's easy to write a fraction. Here's an example that has a terminating decimal. And what is the decimal place of the 5? It's the rightmost non-zero digit. Right as you go to the right, that 5 is the last one before we start to hit just zeros. Well, let's remember our place values. The first place to the right of the decimal is the tenths place. And this is the hundredths place. And that 100 is really what is the key element here. We have 75 hundredths. And that alone tells you what the fraction is. It's 75 hundredths. But this is not reduced. We have to reduce this. Can you see that 25 is the greatest common factor between 75 and 100? You could figure it out using prime numbers and all that stuff, but 25 is the biggest number that'll divide into both 75 and 100. 25 goes into 75 3 times and into 100 4 times. So 75 hundredths is 3/4. So 0.75 is 3/4. Do I have another one? Yeah. If there's a whole number part, we can break it apart and then ask what's the fractional part here, the 0.125. It terminates, so it's easy to figure out what this fraction is. This last decimal place, what is that? We've got tenths, hundredths. This is the thousandths place. thousandths place. So what we have is 4 plus 125 thousandths. 125 divided by 1,000. So we're using the decimal place to figure out what the denominator is. And then the decimal numbers themselves are in the numerator. Okay, this again can be reduced. Let's see, 25 is maybe an easy way to divide in. 25 goes into 125 5 times, and 25 goes into 1,040 times. And then 5 goes in, right? 5 goes into itself once, and 5 goes into 48. So this is really 4 plus an eighth, which as a mixed number would be 4 and an eighth. If you're trying to convert repeating decimals into fractions, you need to have more advanced techniques than what I'm just showing here. And I don't want to go into it here. Lastly, let's convert a fraction into a percent. Converting a fraction into a percent. And the way you do this is first you have to convert the fraction into a decimal number, and then you move the decimal point 2 places to the right and add the percent symbol. Okay, so 1/5. What is that as a decimal number? 5 goes into 1. We see it's 0.2. So this is 0.2. If we move the decimal point 2 places to the right, so I'm going to rewrite it here. I'll write 0.2, but I'll cross out this decimal and go 1 and 2 to the right. We see this empty spot. We're going to put a 0 in there. So we now see that, oh, and I need to put the percent symbol. If I move the decimal point, I need to put the percent symbol. Otherwise, it isn't equal. All right, so this is just in a clean version here, 20%. 1/5 is 20%. So do you get the idea? You convert to decimal, move the decimal point 2 places to the right, and add a percent symbol. Okay, that's it. Hope you've enjoyed the fraction series. We'll see you for the next series or whatever is happening.